Alright, good afternoon and welcome to Mathsatoka online class. Today we'll be solving some beautiful questions, and the first one we're going to look at is number one. Number one said let P be the set of prime numbers, prime factors of 42, and Q be the set of prime factors of 45. Okay, find P intersection Q. Solution. Now, first of all, what are prime factors? First of all, we need the factors of 42. Factors of 42 are any number that can divide 42. That is factors of 42. Then, prime numbers are those numbers that only two things can divide them, which is itself and 1. So, which prime number you know that can divide 42? That's the meaning of prime factor. Prime factor means that what? Any prime number you know that is a factor of 42. Okay? So 1 is not a prime number, so we start from 2. 2 is a prime number. Can 2 divide 42? Yes. 2 is part of it. 3 is a prime number. Can 3 divide 42? Yes. 3 is part of it. 7 is a prime number. Can 7 divide 42? No. So what I have is 5 again. 5 is a prime number. Can it divide 42? No. So I have the only prime factors of 42 is 2 and 3. Then for Q, the same thing. Prime factors of 45 are those prime numbers that can divide 45. So can 2 divide 45? No. But can 3 divide 45? Yes. 3. 5. Can 5 divide this? Yes. 5. So the prime factors of 45 are what? 2, 3, and 5. Then P intersection Q is now what they have in common. And you see that the only thing they have in common is 3. Okay? Number 2 said evaluate 10 combination 7 times 11 permutation 2. 11 permutation 2. Okay? This one is very simple. Solution. 10 combination 7 times 11 permutation 2 is equal to, for this one, 10 factorial all over 7 factorial, then 10 minus 7 factorial, times 11 factorial all over 2 factorial, then 11 minus 2 factorial. So I'm having 10 factorial all over 7 factorial 3 factorial, times 11 factorial all over 2 factorial, this minus this, 9 factorial. So from here I can have that 10 factorial is 10 times 9 times 8 times 7 factorial all over 7 factorial times 3 times 2 times 1. Okay? Times 11 times 10 times 9 factorial all over 2 times 1 times 9 factorial. You know, the reason I stopped at 9 factorial here, I'm supposed to have 9 times 8 times 7 till I get to 1. But since I have 9 factorial at the denominator, I can cancel it. That's why I stopped here. So that's the same thing here. 7 factorial can cancel 7 factorial. 9 factorial can cancel 9 factorial. And I'm having, in fact, 3 can take care of 9 here to have 3 here. And 2 can take care of this to have what? 5. And 2 can take care of this to have what? 4. So I'm left with 10 times 3 times 4 times 11 times 5. Okay? So, and if you do this, you are going to have 13,200. Okay? 13,200. Now, question number 3 says the number of elements in the power set P of S of the set s, which is equal to 1, 2, and 3, okay, is dash. Solution. Now we have that s is equal to set 1, 2, 3, okay, which means that the number of elements in this set is just 1, 2, 3 elements, not because it ends in 3, but because there are just 3 elements here. So my n is 3. Then power of set s means it has a formula. It means the number of all the subsets of set s, but it has a formula which is 2 raised to power n, which is what? 2 raised to power 3, which is 2 times 2 times 2, which is 8. Okay, so question number 4. Question number 4 said that we should find n if n combination 6 is equal to n combination 12. Okay, now what do we do here? From this one I have n factorial all over 6 factorial, then n minus 6 factorial is equal to n factorial all over 12 factorial, then n minus 12 factorial. Okay, now n factorial at numerator can cancel n factorial at numerator, so I'm left with 6 factorial into n minus 6 factorial is equal to 12 factorial into n minus 12 factorial. Now if you look at this now, for these two things to be equal, if I have 6 factorial here, I need to have the same 12 factorial here. So this should be 6 factorial 12 factorial, or this one will be 12 factorial 6 factorial, so that they will be the same thing. Okay, so which means that n minus 6, I should equate it to 12, because I need to get 12 factorial here as well. I'm equating it to 12. Okay, so which says that what? N is equal to what? 12 plus 6. So n is equal to what? 18. Or I will say that this side is supposed to have 6 factorial, which is what? N minus 12 is equal to what? 6. Okay, in fact, okay, let me do it this way so you get it very well. Now for this side, okay, this thing here supposed to be equal to this 12 factorial, because I need 6 factorial 12 factorial so that it will be equal to the same thing here. So I can say that n minus 6 factorial is equal to what? 12 factorial. Or I say that what? 6 factorial, this one, is equal to what? N minus 12 factorial. Anyone I like. Now factorial take care of factorial. I'm having a what? N minus 6 is equal to 12. Therefore n is equal to 12 plus 6. So n is equal to what? 18. Or I say that what? Factorial take care of factorial. I'm having that 6 is equal to n minus 12. So this one can come here. 6 plus 12 is equal to n. Therefore n is equal to what? 18. You see? The same answer. So that is the only thing that will make them to be equal. Now number 5. Number 5 says that we should simplify 2 root 2 minus root 3 all over root 2 plus root 3. Okay, solution. Now this is simply rationalization of surd. Okay, so I'm having 2 root 2 minus root 3 all over root 2 plus root 3 times the conjugate. You are going to rationalize with the conjugate. If it's plus here, you are going to rationalize with minus, because minus is the conjugate. So this is root 2 minus root 3 all over the same thing here, root 2 minus root 3. Okay, so let me clear the bracket. Use the one in top, multiply numerator, and denominator multiply denominator. Now root 2 times root 2 root 2 times root 2. 2, the one at the back, multiply the one at the back, and the one inside, multiply the one inside. 2 times 1 is 2, bracket. Root 2 times root 2 means root 4, and square root of 4, root 4 means what? 2. So when root 2 times root 2, the answer is simply 2. Okay, I'm done with this one, multiplying this one. So this one again will still multiply this one. 2 times the one back here, I'm having minus 2. Then root 2 times root 3 is giving you root 6. Okay, the same thing here. Minus 1 here times 1 here, I'm having minus root. This time this is what? 6. Minus times minus is plus. Root 3 times root 3 is root 9, which is what? Root 9 is 3. All over. Now, in fact, at the denominator, just do the first one times the first one minus. The minus must be there. The second one times the second one. Anytime you are doing rationalization, that's what you will do. So this time this will give you just 2 minus original minus. This time this will give you what? Just 3. Okay, or you do this times everything here and this one times everything here, you will still get this answer. So I am left with this time is 4. 4 plus 3 will give you what? 7. Minus 2 minus 1 will give you what? Minus 3 root 6. All over. This minus this is giving me minus 1. Okay? Now let me share it for them. This is what? I can share the minus 1 for them, which is what? 7 divided by minus 1 minus 3 root 6 divided by minus 1. So, which is giving me that what? In fact, minus plus is minus, which is minus 7. Minus minus is what? Plus 3 root 6. Okay, which can be written as 3 root 6 minus 7. Okay, so that is the answer for that. Now, number 6. Number 6 said, given that log 7 is equal to 0.845 and log 3 is equal to 0.477, then the man said find log 7 in bracket of root 7 base 3. Okay, solution. This is a very simple something. They say we should find this. We should find log 7 bracket root 7 base 3. Now, their own is in base 10 and my own is in base 3. If I want to bring in that base 10 that their own have, I'll have the what? Log the one up, which is 7 root what? 7. Okay, 7 bracket root 7, all base 10 all over the one down. Log 3 base 10. Okay, according to the law of logarithm that said that log m base n is equal to log, if you want to bring in another base by yourself, maybe I want to bring in base x, it will be log m the one up base that x all over log n now base that x. Okay, that is one of the laws of logarithm. If you don't understand, you can watch our video on logarithm. Okay, so this is equal to log. Now, what brought about times in logarithm is addition. So I can have log 7 base 10 plus log root 7 base 10. Don't forget, all over log what? 3 base 10. Now, root 7 is the same as saying 7 raised to power 1 over 2. That's the same thing. Okay? So this thing is the same as saying log 7 base 10 plus log 7 raised to power 1 over 2 base 10. Okay? All over log 3 base 10. Okay? Now, don't forget that there is a law of logarithm that said that the power can go to the back. There's a law of logarithm that said if I have log a raised to power x base b, that the b can go to the back to become x times log a base b. Okay, so this 1 over 2 can go to the back, so I'm still left with log 7 base 10 plus 1 over 2 log 7 base 10. Okay, all over log 3 base 10. Okay, so this is something I'm saying they gave me this one, which is what? 0.845 plus 1 over 2 into the same 0.845. Okay, now divided by, they gave me this one as 0.477. So I'm having 0.845 plus half of this. Half of this will give me 0. Okay, let's do it. So I'm having a 0.845 divided by 2. Okay, so it's giving me 0.4225 all over 0.477. So if you add everything and divide, you will be having 2.657. Okay, so as simple as that. Why it's very long is because I'm explaining. But if you just want to solve it, you will know that what brought about the multiplication is addition. So that square root means you divide by 2. So you just say half of this plus itself divided by this one, you get the answer. As simple as that. Okay, so number what now? Number 7 said I raised to power 2475. Now, I told you in my video on complex number that if you have this thing, the only thing you need to check is, first of all, if the power is an odd number or even number. So if it's an odd number, if n, watch, if n, I raised to power n, okay? If in fact, your answer will give you I, if n is what? If n is odd and n divided by 2, okay? The whole number part of n divided by 2 is even number. It will give you minus I if the same n is odd and the whole number part of n over 2 is odd again, okay? Then it will give you 1 if n is even, and the whole number part of n over 2 is equally even, okay? But it will give you minus 1 if n is even, okay, and the whole number part of n over 2 is odd. So which means if it is even, I'm expecting number, but if it is odd, I'm expecting alphabet. Then how do I know when to choose the negative and positive? Is by dividing it by 2. Half of it, the whole number part of half of it, if it is even, I'm taking positive, but if it is odd, I'm taking negative, which means since I'm having I raised to power 2475, this is odd, so the answer I'm expecting is either I or what? Minus I, because it is odd. Now I will now divide it by 2. If you divide it by 2, you are going to have if you divide it by 2, 2475 divided by 2 is giving me 1237.5. But I don't need the point, like I said. We only need the whole number part, and you can see that this whole number part is equally odd, so my answer will be the negative 1. So the answer to this is simply minus I. As simple as that, okay? So you can watch my video on complex number to help you to understand it very, very well, okay? Number 8 said, how many words can be formed? How many words can be formed by using all the letters of Adamma? All the letters of Adamma if the two m's are to be separated, Now, how do you solve this kind of thing? First of all, we cannot get when they are separated. We can only get when they are together. So first of all, let's get without restriction. Without restriction. Now, without restriction means without any condition. The number of words that can be formed with the word Adamma is 1, 2, 3, 4, 5, 6. We say 6 factorial all over. A is how many? 1, 2, 3. You put it in the denominator, 3 factorial. D is how many? 1. I'm supposed to put 1 factorial here because, but 1 factorial is 1, so we don't need it. A again, I'm done with A. M is 2, so I'll put 2 factorial. So this thing will give me it will give me, what am I saying, 60. Okay, you can do it. That is 60. I hope you know how to get this one. Is 6 times 5 times 4 times 3 times 2 times 1, and this one will be 3 times 2 times 1 times 2 times 1, which will give you 60 without restriction. Now when the m are together, if the m are together, you have A, D, A, then the m like this being together, okay, then I'm now having an A here. So when they are now together, I'm having 1, 2, 3, 4. They are now serving as 1, 1, 2, 3, 4, 5, which is 5 factorial all over. A is how many? 3 factorial. D is how many? 1. I cannot write it. M is how many? 1. They are now together as 1. So what I have here, if you do everything here, you are going to get 20. Okay. So when they are not together, when this one is when they are together. So when M are separated, should be without restriction, which is 60, minus when they are together, which is what? 40. So 40 words can be formed from that all the letters of that word Adamma. Okay, so number 9 Number 9. Number 9 said to prove a sequence of statements okay, we have that Sn by induction, okay, comma, we prove S1 and we also have to assume, okay, assume Sk and prove Sk plus 1 statement, okay. So that is just it. You just know that you need to prove S1, then assume Sk and prove that Sk plus 1 implies Sk. That's all. So that is that. Number 10 question here says find the ninth term of the following series, and they have 5 plus 10 plus 20 plus 40 plus dot dot dot. Now solution. Now if you look at this, you will see that in this sequence I have the first term is 5, okay, then the next term is giving me 5 plus 5, the last answer plus itself, okay. The next term should be giving me the 5 plus 5 10, which is this 10 plus itself, okay, which is this 20. Are you getting it? Plus the next one should be giving me what? 20 plus 20, which is 40. In fact, let me just be writing it straight. So I'm having 5, okay, 5 plus 5 10, 10 plus 10 20, 20 plus 20 40, 40 plus 40 80, 80 plus 80 160, 160 plus 160 320, 320 plus 320 is 740, 740 plus 740, 740 plus 7 plus is it 740 or 640? Sorry, 640. Okay, 640 plus 640 is 640, 640. So I'm having 0 8 12. So I'm having 1 2 8 0, 1 2 3 4 5 6 7 8 9. So the ninth term there is simply 1 2 8 0. Okay, that is that. Now number 10 says is that, did I skip anyone? Okay, sorry, this is number 9. Okay, this is number 10. Okay, number 11, not number 10 again. Number 11 said that if x is equal to a set of x which is an element of a natural number, okay, such that x is a prime number, less than, okay, prime number less than 9, okay, prime number that is less than, okay, prime number less than 10, okay, prime number that is less than 10, okay, then they now say that y is equal to the set of a set of y which is an element of an integer such that 0 is less than or equal to y which is less than or equal to 10, okay. They now say we should find y intersection y minus x. Okay, solution. Now first of all, let us get, now they wrote this set in building form, okay. So let's now list the set. After writing it in building form, let us now list it. So let us list the set. They have written it in building form, so let us now list it. Okay, So listing the sets, the first one is x. X is a set of all prime numbers that are less than 10. 1 is not a prime number, so 2 is a prime number. Remember, prime numbers are numbers that can only be divided by itself and 1. Okay, but 1 is not a prime number. So 3, 4, 2 can divide 4, so 4 is not there. 5, 7, is 9 a prime number? No. 3 can divide 9, so 9 is not a prime number. I'm done with here. Then, but for y, y said that y will start from 0 and end in 10 because of the equality sign. So I'm having 0, 1, 2, up to 10. Okay? Now, first of all, let's get y minus x. Y minus x is equal to the set of, now, from y, remove x, because they wrote y first. Remove x. So if I remove 2, 3, 5, and 7, I'm having 0, 1, 2 is already here, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? Then, the intersection of these two things now, y intersection y minus x is simply what these two have in common. Sorry, what these two have in common. And what they have in common is this one, which is 0, 1, 4, 6, 8, 9, and 10. Okay? So, that is that. Okay. So, but if the question say prime numbers that are less than 9, I think the question say prime numbers that are less than 9. Okay, sorry, not 10, because I'm not seeing the option here. You know, the question, there is a little problem there. So less than 9 means oh sorry, prime numbers that are less than 9. Okay. Yeah. So what number is that? Okay, sorry, it's prime numbers that are less than 10, but here it said less than, not equal to, less than. So it started from 0 and ends in 9, so it ends in 9, not in 10. Okay, so this minus this is without 10, so, and without 10, so this is the answer. Okay, so that is that. So number 12. Okay, number 12 said if alpha and beta are the roots of 2x squared minus 3x is equal to 5. Okay, then evaluate alpha squared plus beta squared. Okay, it's very simple. Now, first of all, solution, you have to arrange it normally to become 2x squared minus 3x minus 5 is equal to 0, so that a is equal to 2, b is equal to minus 3, and c is equal to minus 5. Okay, so alpha squared plus beta squared is equal to what? Don't forget, it's what? Alpha plus beta all squared minus 2 alpha beta. Okay, don't forget that alpha plus beta, the formula is minus b over a. Don't forget the all squared minus 2e to alpha beta, the formula is c over a. Okay, so which is what? Minus into, this one is what? Minus 3 all over what? All over 2. Don't forget that it is squared minus 2 into minus 5 over 2. Okay, so I'm having this is 3 squared is 9 over 4 minus, this time this will give you plus 10 over 2. So the LCM there is 4. Okay, and 4 into this is 9 plus 20, which will give you what? 29 over 4. Okay, so 29 over 4 is the result. So the next one, number 13. Okay, let me check my time. Okay, number 13 said the nth term, find the nth term of a geometric the n term of a geometric is given as, or find the n term of a geometric sequence. It can be written in two forms. Now the n term of a geometric sequence is given by a r raised to power n minus 1. That's all. Or like this, Tn is equal to a r raised to power n minus 1. This is the formula for what? GP, geometric progression or geometric sequence. Sometimes we call it exponential sequence. They can call it geometric sequence or geometric progression or exponential sequence. Please note that. Number 14. Number 14 says that we should evaluate root 3 plus I all raised to power 5. Now I'm going to solve this in two ways. Okay, solution. The first way is just by saying root 3 plus I times root 3 plus I times again root 3 plus I times root 3 plus I, 1 2 3 4, and again times root 3 plus I. Okay, so you can times it like this, you will still get the same answer. Okay, but me, I know that these two will give me root 3 plus I all squared. Then another all squared will make it how many? 1 2 3 4. We make it 2 times 2 4. Then times the remaining one, root 3 plus 1. Why I did it like this is because I can get this one by saying the formula I gave you, that is, this one means whenever the squared is outside, it means square the first one, multiply the first one and the second one, double it, square the last one. If you can say it, you can do it. Okay, square the first one, you have a squared, multiply the first one and the second one, ab, double it, you have 2ab, square the last one, you have b squared. So that is what I want to do here, and then repeat it again. So square the first one, I'm having 3, multiply the first one and the second one, I have root 3i, double it, I have what? 2 root 3i, then square the last one, I squared is minus 1. So I have cleared the first square, let me put my second square, then times root 3 plus I. Okay, so this and this will give me 2. So I'm having 2 plus 3, sorry, let me write it here so that you can see it very well. So this minus this will give me 2. So I'm left with 2 plus 2 root 3 I all squared times then root 3 plus I. Okay, so let us do it again. Square the first one, 4. Multiply the first one and the second one, you have 4 root 3i, double it, you have what? 8 root 3i, then square the last one. Square of 2 is 4, square of root 3 is 3, square of I is minus 1. Okay, don't forget. So don't forget root 3 plus I. Now everything here is giving me minus 12. Minus 12 plus 4 is giving me 8. So I'm left with 8 plus 8 root 3i. Okay, so then this answer now times root 3 plus I. Okay, so that is question number 13. Okay, so what do I have now? I'm left with 8 times this will give you 8 root 3. 8 times this will give you what? 8i. This time this will give you 8 times 1, 8. And 3 times 3. Root 3 times root 3 is just 3. Putting my I. Then plus 8. 8 times this is giving me minus, not plus, because I times I is minus 1, so minus 8 root 3. Okay, so what I'm left with, I think there should be a mistake somewhere. Let me check. Okay, let me check if there is a mistake somewhere. This is this square the first one, I have this, multiply the first one and second one, double it, I have this, square the last one, I'm having 1. Okay, this and this is giving me 2 plus 2 root this. Okay, square the first one, I have this, multiply the first one and second one, double it, I have this, square the last one, I'm having oh, this is giving me minus. Okay, This is giving me 3 times 12 minus 12 plus 4, which will give me minus 8. So this is where my mistake lied. Okay, so this is minus 8, not plus 8. So minus 8 times this will give you minus 8 root 3. Minus 8 times this will give you minus 8i. Okay, now this time this will give you 8 times 1 is 8. Root 3 times root 3 is 3. Then put your I. Okay, now this time this will give you plus 8 root 3i. Okay, sorry, in fact minus, because I squared is minus 1. This times 1 is this, then I times I is minus 1. So I'm left with this, and this will give you minus 16. Minus 16 root 3. Okay, and so if you look at here, 8 times this is 24. 24 minus this will give you plus 16. Plus 16i. So if you bring out minus 16 in bracket, so you'll be left with here will now be plus root 3 minus I. Okay, this could be the answer, or you will decide to bring out 16 itself. If I bring out 16 itself, I'm left with minus root 3 plus I. Any of the two is the answer. Okay, so that is that. Now we have used the first method. Now the second method we are going to use is the polar form method. The polar form method. Okay, the Movian theory, polar form method. Solution. Now to solve this, the first thing you need to get is your radius. Okay, and the radius r is simply the square root of what? S squared plus y squared. Don't forget that z is equal to x plus what? yi or iy. So which means x is the first one and y is the coefficient of I. Okay, so I'm left with what? The square root of root 3 all squared plus 1 squared, because the coefficient here is 1. So which is what? The square root of 3 plus 1, which is what? Root 4, and root 4 is what? 2. So my r is simply 2. Now the next thing you need to find is your angle. Theta is simply the tan inverse of y over x. Okay, absolute value. Don't forget absolute value. Absolute value of this. So my theta is simply the tan inverse of my y is 1 all over root 3. Okay, now tan inverse of 1 over root 3 is 30, because tan 30 is 1 over root 3. So I'm left with what? This is absolute value. I'm left with 30. So my angle is 30 degrees. Okay, so since my angle is 30 degrees, I want to leave this answer so that you will see that they are the same thing. Let me write the answers out. The answer I got is either minus 16 root 3 minus I, okay, minus I, or 16 into minus root 3 plus I. Okay, so let me clean here. So now I have gotten my angle and my theta. So my z now is equal to what? R in bracket of cos theta plus what? I sin theta. This is the polar form. So my z is equal to, what is my r? 2 in bracket of what? Cos 30 plus what? I sin 30. Is it not? Now, but what I'm looking for is z raised to power 5, because that thing is raised to power 5. So z raised to power 5 is simply 2 cos 30 plus I sin 30, like this. Then what am I saying? Everything should be raised to power 5. So I'm left with 2 raised to power 5 in bracket of cos 30 times 5 plus I sin 30 times 5. So which is what? Into, in fact this one is 32 into cos, this time this is 150 plus what? I sin 150. Now 150 is second quadrant. Look at it. CAST. 150 falls in second quadrant, and it's only sign that will be positive in the second quadrant. So this thing is set as saying 32 bracket cos 150 will give you minus cos 30, and cos 30 is root 3 over 2. So minus root 3 over 2 plus sign is going to be positive, so I'm using plus, and sin 30 is 1 over 2. So plus 1 over 2i. Okay, now they have 1 over 2 in common. So if I bring out 1 over 2 in common, I'm having 32 times 1 over 2 in bracket of what is remaining here is minus root 3 plus I is remaining. So this divided by this, I'm left with 16 in bracket of what? Minus root 3 plus I. Did we get the same thing? You see, that is this. Or if you bring out minus outside, you have minus 16. This one will change to root 3, and this one will not change to minus I. See, we got the same answer. So any method you like, you will still get the same result. Okay, so let's go to the next one. So the next one says, that is number 15. Number 15 said, compute the argument of z, okay, if that z is equal to what? 1 plus I. Okay, and argument is theta. Now don't forget that my argument is theta, so theta is equal to what? The tan inverse of the absolute value of what? Y over x. So which is equal to what? The tan inverse of the absolute value of y is 1 and x is 1 over 1. Okay, which is what? The tan inverse of 1. And tan inverse of 1, tan 45 is 1. So which means tan inverse of 1 is 45 degrees. Okay, so that is that. 45 degrees. So the next one, number 16. Number 16 said we should just find 6 permutation 4. Very simple. 6 factorial all over what? 6 minus 4 factorial, which is what? 6 factorial 2 factorial. And 6 factorial 2 factorial, number what? Number 16. So 360 degrees. That is 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial. 2 factorial cancel 2 factorial. 360 degrees. This time, this time, this time, this. So number 17. Number 17 said that we have x squared y all squared in bracket of x cubed y all squared all over x y all raised to power 4. So let us first of all clear it. This squared will give you x raised to power 4. This squared will give you y raised to power 2. This squared will give you x raised to power 6. 3 times 2, 6. And this square will give you y raised to power 2 all over. This square will give you x raised to power 4, and this square will give you y raised to power 4. In fact, you can start cancelling out if you don't want to use indices. But if you want to use indices, you are going to have x raised to power 4 plus 6, then minus 4, because this one is denominator. Then y will now be what? 2 plus 2 minus 4. So I'm left with x raised to power 6 here. Then I'm left with y raised to power 0 here. And x raised to power 0 is 1. So this times 1 will give you x raised to power 6. Or you cancel out. If you want to cancel out, 4 will take care of these 2. And this 4 will take care of this 4. So I'm still left with x raised to power 6. So anyhow you want to do it, you will still get the same result. Number 18. Children of God. Number 18. Number 18 said, I raised to power, simplify, I raised to power 4n plus 3. Okay? Now, according to indices, what normally give us plus is times. So let us separate it. I raised to power 4n times I raised to power 3. Okay? So which is this is what? Let me separate this one. I raised to power 4, all raised to power n, then times I raised to power 3. Now, I raised to power 4 is 1. Then all raised to power what? N times I raised to power 3 is minus I. You can check it out yourself. Now 1 raised to power anything is 1. So I'm left with 1 times minus I. So my answer is simply minus I. Number 19. Number 19. Okay. Number 19 said, which of the following is a well-defined set? The first one said, all the colors in a rainbow. I think that's the answer. All the colors in a rainbow. The other one said, all the points on a straight line. All the points on a straight line. They are not well defined. All the hardworking teachers in a school. not really well defined. So that's the answer. So number 20, that one there is no solving. Number 20 said solve the absolute value of 4x minus plus 3, okay, is less than or equal to 5. So how do you remove absolute value? You are going to bring this to the other side, so it's going to be minus 5. Bring the negative of this one, put the same sign, then you have what? 4x plus 3, then repeat it is equal to what? 5, like this. That's how to remove absolute value. Bring the negative of this one to the other side, and then you are done. Now take anything you do to the left hand side, do to the right hand side. So this is plus 3. Moving here, I'm going to have minus 5 minus 3 is less than 4x is remaining here, is less than 5. The same thing will come here, minus 3. So I'm left with minus 8 is less than or equal to 4x, which is less than or equal to what? 2. Divide everybody by 4. Minus 8 over 4 is less than or equal to what? 4x over 4, which is less than or equal to what? 2 over 4. Now if you talk about here, I'm having minus 2 is less than or equal to what? X, which is less than or equal to 1 over 2. So that is the answer. So if you want to write it, you say that what? X is an element of a closed set, because of this equal to a closed set of minus 2 comma 1 over 2 closed again. But if there is no equal to, it will not be an open set like this if there is no equal to. Okay, so the interval of these two. So number 21 says okay, this is number 21. Sorry, this is number 21. So number 20 said that if alpha and beta are the roots of 3x squared plus 4x plus 5 equal to 0, then we should find alpha squared plus beta squared again. Okay, we know the formula. Alpha squared plus beta squared is equal to what? Alpha plus beta all squared minus 2 alpha beta. So which is what? Alpha plus beta, the formula does not change. Minus b over a. Don't forget the all squared. Minus 2 into this one does not change. C over a. So which is what? Minus my b is 4. A, b, and c. So which is minus 4 over 3 all squared minus 2 into 5 over 3. So what do I have now? 16 over 9 minus 10 over 3. So my LCM is 9. 16 minus 30. So I'm having minus 14 over 9. As simple as that. Minus 14 over 9. So that is for number 20. Okay. Then let's go to number 22 because we have solved number 21. So number 22. Number 22 said find the sum. Find the sum of the arithmetic sequence. Now, our arithmetic sequence is simply AP, okay? So, I'm having 2 plus 3 whole number, 1 over 2, okay? Plus 5, plus ... plus 53. Solution. Now, we don't know the number of terms of this thing before we now talk about getting their sum. So we need to know the number of terms they are. But first of all, I know my A. My A is the first term here, which is 2. And the common difference is simply the second term minus this, or this one minus this. So I'm having 3 whole number 1 over 2 minus 2, which will give you 1 whole number 1 over 2. I have gotten my common difference. Now let me get my n, the number of term. I know that my Tn, the formula is what? A plus n minus 1 bracket d. And they say that Tn is the same thing as the last term. Okay? Don't forget that Tn is the same thing as the last term. So which is what? The 53 I'm seeing here. So let me put it. 53 is equal to my A is 2 plus n minus 1 my d. In fact, this is set as 5 over 2. Let me leave it as 5 over 2. Okay? Now, so to remove the over 2 here means multiply everybody by 2. So if I multiply everybody by 2, I'm going to have 53 times 2. So 53 times 2, 106 is equal to this one times 2, 4, plus this one times 2. I'm left with 5 into n minus 1 because the 2 will cancel these 2. So collect like terms to have 6 minus 4 is simply 5 into n minus 1. So therefore 102. So therefore 102 is equal to 5 into n minus 1. So divide everybody by 5. N minus 1 is equal to 102 divided by 5. So n minus 1 is equal to 102 divided by 5. Okay? 102 divided by 5. Am I getting it? Number 22. Okay, 102 divided by 5. Okay, 20.4. Okay, let me leave it like this. 102 divided by 5. Okay, so 102 divided by 5. Huh? The n term cannot be in fraction. Is there any problem anywhere? How did I get 5? Okay, sorry, 3. 3 times 2 times 1, 2 plus 1, 3. Is 3 over 2, not 5 over 2. Kingsley. So here is 3, not 5. 3. So divided by 3. I know there should be a mistake somewhere. Because the n, so n minus 1 is 102 divided by 3. 102 divided by 3. 34. 34. So because I know that n must be a whole number. So 34 plus 1. So n is now 35. So we have 35 n term. So which means sum of term Sn is equal to n over 2 plus, bracket what? 2a plus n minus 1 bracket d. Don't forget this formula. This is formula for sum of what? Arithmetic progression. So you can check my video on arithmetic progression. So which means what? S35 is equal to what? 35 over 2 bracket 2 into 2 because my a is 2. Okay? Plus 35 minus 1 which will give you 34. 34 bracket my d is what is my d? 3 over 2. Okay? My d is still 3 over 2. You close. So the sum of term Sn is simply 35 over 2 into, in fact, 2 cancel here will give you 17, right? Then that's 17 times this. So I'm having, this time this is giving me 4 plus 34 divided by 2. I have 17 times that 3 that is there. That is 51. Okay? So I'm left with 35 over 2 times 55. So which is what? Plus 4. 55 times 35. So I'm left with 1925 over 2. So 1925 over 2. So if you put it in whole number, you are going to have, so I'm going to have 962 whole number 1 over 2. Okay, so that is the sum of the nth term of that sequence. So that is that. So the next one, number what now? Number 23. Number 23. Number 23 said, let Sk be the statement. Let Sk be the statement 1 plus 3 plus 5 plus ... plus 2n minus 1, which is equal to n squared. Okay? In fact, it's supposed to be let Sn, because this thing is in n, but if it is Sk, here will not be k. So which means Sk should be what? 1 plus 3 plus 5 plus ... plus. Anywhere you see n, put k, which is 2k minus 1 is equal to what? K squared. So Sk plus 1, which is even the one they are asking me, So they say we should find sk plus 1. So anywhere we see k, we put k plus 1. So it will be 1 plus 3 plus 5 plus dot 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 plus 2 into k plus 1, then minus 1 is equal to k plus 1 all squared. So I'm left with, if I repeat the same thing here, I'm left with, this time this is what? 2k, this time this is 2. 2 minus 1 is 1. Okay, is equal to k plus 1 squared. So that is just the answer, D. Now number 24. Number 24. Number 24 said, given that z is equal to 2k minus 1 plus I into 3 minus k, okay, is purely real, comma, then find the real part of z. Okay, okay, so if this thing is purely real, it means that everything here, it should be 0. So it means that solution, it means that I into 3 minus k should be equal to 0i. Okay, so I will take care of I, which means 3 minus k is equal to 0. So therefore 3 is equal to k. So I've gotten my k. So the real part now means anywhere you see k, put 0 in this real part. So the real part of z is simply the one without I, which is just 2k minus 1. So but I've gotten k to be 3. 2 into 3 minus 1, which is what? 6 minus 1, which is 5. So the real part of this z is simply 5. So you see, they don't have question to ask. Number 25. Number 25 said number 25 said find k such that z, which is equal to k plus 1, okay, such that z, which is equal to k plus 1, okay, plus I into 3 plus k is purely imaginary. Don't forget that if it is purely imaginary, it means that the real part will not be 0 if it is purely imaginary. So let's equate the real part to be 0. So if you equate the real part to be 0, you see that k is simply minus 1, even without solving anything. So let's equate this real part, which is k plus 1 to be 0. Therefore k is simply minus 1. Number 26. You don't have any question to ask. Number 26 said find x if 36 raised to power log 3 base 6 is equal to x. Okay, solution. Now anytime you have that the log is at the power, say let that log be equal to something. So let log 3 base 6 be equal to y. Can this carry this? Yes, which means 6 raised to power y is equal to 3. Just stop here, then go back to the equation. Now say that 36 raised to power, you have called everybody here y, so 36 raised to power y, which is same as what? 6 raised to power 2 all y. 6 raised to power 2 is still 36. They can change, which is what? 6 raised to power y all squared. But I've gotten that 6 raised to power y is 3, which is what? 3 squared, and 3 squared is what? 9. As simple as that. Number 37 and number 27. Number 27 says evaluate 4 root 2 plus root 50 minus root 18. Solution. So I have 4 root 2 plus, now for root 50, share it. 50 2 divide 25, 5 divide 5, 5 divide 1. If you are double, stay outside. If you are single, stay inside. Double, take one of them, 5 outside, but the 2 that is single will stay inside. Minus, do the same thing to 18. 18, 2 divide 9, 3 divide 3, 3 divide 1. Double, stay outside. Single, stay inside. Now, in addition and subtraction of surd, we are interested in only the coefficient. So this plus this, 9 9 minus 3, 6. So my answer is simply 6 root 2. As simple as that. 6 root 2. Okay. So let's move to the next one. Number 28. Number 28. Number 28 said we should find x if 6 raised to the power x over 3 is equal to 72. Okay, let's cross multiply. So this can be 72 over 1. If I cross multiply, I have 6 raised to the power x is equal to what? 3 times 72. So 6 raised to the power x is equal to what? 216. So share 216. 216. 6 divide 36. Huh? Sorry, 216 divided by 6. 216 divided by 6. I'm having 36. Is it? 216 divided by 6. 36. Wow. 6 divide 6. 6 divide 1. So this is 6 raised to the power x is equal to 6 raised to the power 3. So I'm having that x is equal to 3. Okay? The next one. Number 29. Number 29 said evaluate a plus b if 105 plus root 75 is equal to 5a plus b root 3. Okay, so equate root to root. Equate the one that is not in root to the one that is not in root, which is 5a is equal to 105 and b root 3 is equal to what? Root 75. So therefore my a is what? 105 over 5 and b root 3 is equal to, reduce 75. 75 3 divide 25, 5 divide 5, 5 divide 1. If you are double, stay outside. If you are single, stay inside. Root 3 will cancel root 3. Therefore my a is equal to 21, right? 21, and my b is equal to 5. So they say we should find a plus b. A plus b is simply 21 plus 5, which is simply what? 26. As simple as that. Number 30. Number 30. Number 30 said that if a is equal to 5, b is equal to 2, c is equal to -3. They say evaluate a bracket 3b minus c all over what? 2 bracket a minus 2. Okay, simple. Just put everybody now. 5 into 3 into 2 minus into -3. Everybody over 2 into 5 minus 2. Okay, so which is 5 into, now 3 times 2, 6, minus plus 3 all over what? 2 into 3. So I'm left with 5 into 9 all over 2 into 3. Now 3 can take care of this to have 3, which is 15 over 2. Okay, 15 over 2. So that is simple arithmetic. Simple arithmetic. Number 31. Number 31 said let z be equal to root 3 minus I. Then I say find the magnitude of z. Magnitude of z means r, and don't forget our r is what? The modulus. The modulus is simply x squared plus y squared, which is what? The square root of this is x and y, which is what? Root 3 all squared plus -1, the coefficient all squared, which is what? The square root of 3 plus 1, which is what? Root 4, and root 4 is what? 2. Okay? Number 32. Number 32. Number 32 said sum the following. Sum the following sequence to infinity. Sum the following sequence to infinity. They said 3 plus 3 over 2 plus 3 over 4 plus 3 over 8 plus ... In fact, even if they didn't tell you to sum to infinity, as far as it does not have end, we are summing to infinity. Okay, so solution this is geometric progression. So my A is just 3 and my R is simply this divided by this, or this divided by this, or this divided by this. You get the same answer. So this first, 3 over 2 divided by 3, which is same as what? 3 over 2 times 1 over 3. So this take care of this. I'm left with 1 over 3. 1 over 2 as my R. Then sum to infinity. Don't forget that this R is less than 1 and it has two formulas. The first formula said that, let me write it here. The first formula said that sum to infinity is simply A over R minus 1. I started with R, that is if R is greater than 1. But the sum to infinity is simply A over 1 minus R, that is if 1 is greater than R. And 1 greater than R means that R is less than 1. So if 1 over 2, this my R is less than 1. So this is the one I'm taking. So this is equal to what? A over 1 minus R, because 1 is less than, R is less than 1. So I'm left with what? 3 all over 1 minus 1 over 2, which is what? 3 over half, which is what? 3 divided by 1 over 2, which is 3 times 2 over 1, which is 6. So the sum to infinity is 6. Okay? So number 33. We are close to finish. Number 33. Number 33 said in an AP arithmetic progression, A is equal to 1, D is equal to 8, and if an, the nth term is 89, we should find n. Okay, solution, very simple. The nth term of an arithmetic progression is A plus n minus 1 bracket D. Don't forget. So this is what? 89 is equal to my A is 1 plus n minus 1 bracket what? 8. Is it not? So this one can move here to have 89 minus 1 is equal to n minus 1 bracket 8. So 88 is equal to what? N minus 1 bracket 8. If I divide everybody by 8, I'm having that 88 divided by 8 is equal to n minus 1. So 11 is equal to n minus 1. This one moving here. 11 plus 1 is equal to n is equal to n. So 12 is equal to n, which means n is equal to what? 12. As simple as that. So number 34. Number 34 said, which of the following is false? Which of the following is false? They said the first one said that n is a subset of a rational number, and a rational number is a subset of a real number. Is correct. Is correct, because go to my video on number system. So the next one said that n is a subset of an integer. Natural number is a subset of an integer. An integer is a subset of a rational number. Very correct. But this one said that rational number is a subset of another rational number, which is a subset of what? Natural number. Rational number can never be a subset of a rational number. So that is incorrect. So the last one said that integers are a subset of rational number, which is a subset of real number. Very correct. So this one is the one that is wrong. Okay? So number 35. Number 35. Number 35 said express angle 505 degrees in radian. Now, expressing in radian simply means 505 times 180 over 180. But this 180 at the top is pi, because pi is 180, okay? So let's change it to pi. So pi over 180. So let these people now start dividing itself until you get to the lowest. So I'm having, this is same as what? 505 over 180, then leaving your pi. If you divide it to the lowest, let them keep dividing itself to the lowest, number 35. And then you will now have 101. 5 divide here, 101. And 5 divide here, you have 36 pi. So that is the answer. So number 36. Number 36 said, find the principal argument. Find the principal argument of Z, which is equal to 1 over I. First of all, let us rationalize. We don't leave I at the denominator. So I have Z is equal to 1 over what? I times what? I over I. So this time this is I, but I times I is minus 1. So I'm left with what? Minus I. So let me write it very well. The real part is 0, then minus I, the imaginary part. Okay? So, and the argument normally theta is equal to what? The tan inverse of what? Y over X. Absolute value. Don't forget absolute value. Absolute value. In fact, that is even the principal argument. So which is what? The tan inverse of the absolute value of minus 1 over 0. Okay? Which is what? Theta is simply the tan inverse of undefined. Because anything divided by 0 is undefined. And tan 90 is undefined. So the tan inverse of undefined is what? 90 degrees. So it's the answer there. And 90 degrees is what? 180 divided by 2, which is pi over 2. So this is instead of saying 90 times pi over 180. So 0 cancels 0. 9 divided itself 1. 9 divided here 2. So I'm left with what? Pi over 2. I'm left with pi over 2. So number 37. Number 37 said find the exact value. Find the exact value of the sine inverse of minus root 3 over 2. Okay, in radian. Okay, solution. Now, sine inverse of minus root 3 over 2. Now, minus is an sine is an odd function. Okay, what do I mean by odd function? Sine minus theta is written as minus sine theta. Okay, but cos is an even function in a way that cos minus theta is written as cos theta. The minus will not come to the back. Okay, so and tan is equally an odd function. So the only even function we have is cos. Okay, so which means this is written as what? Minus the sine inverse of root 3 over 2. Okay, and sine 30 is 1 over 2, but sine 60 is root 3 over 2. So sine inverse of root 3 over 2 will give me what? 60 degrees. So to convert this thing to a positive number, so let me say that theta is equal to this. So it's supposed to be theta is equal to minus 60 plus. Okay, in fact, let us draw it and know where it will fall. Let us draw it and know where it will fall. This is x over y. Don't forget, x. Okay, let me check. So that I will not make mistake. This is theta. Okay, and I'm having opposite over hypotenuse. Let me say that it is where is this thing falling? I don't know. Okay, first let's say CAST. Okay, so the only place is positive is at the second quadrant. So the only place is positive is at the second quadrant. So we need a number that will fall either at the third quadrant or at the fourth quadrant. So I'm adding 360. So plus 360. So plus 360 because we cannot so which will give me that theta is equal to 300 degrees. So changing 300 degrees, so theta is equal to what? 300 times pi over 180. So this take care of this. And here I'm having 10. So that 3 here. 3 times 6, 18. So I have 6 here. So 2 here, 5. 2 here, 3. So my answer is what? 5 pi over 3. 5 pi over 3. But the answer is not even there. So this is how it's supposed to be. In fact, anytime your theta is a minus and you want to change it to plus, just keep adding 360 until it will eventually fall to a quadrant itself. Okay, so number 38 said that let A be equal to the set of minus 1, 3, 5 and 8. Okay, then I say we should find power of A. Power of A simply means 2 raised to power n, and n is the cardinality of A, which is the number of elements here. 1, 2, 3, 4. They are simply 4 elements, which is 16. That is 2 times 2 times 2 times 2. So number 39 simply said that let Z be equal to what? Minus 2 plus I. Okay, then I say we should evaluate Evaluate z plus z bar. Now z bar is simply the conjugate of z. Solution. Z is, I'm looking for z plus z bar. Now z itself they gave me as minus 2 plus I plus z bar means the conjugate. If here is plus, change it to minus, which is minus 2 minus I. So I'm left with minus 2 minus 2 minus 4. But I minus I is 0. So my answer is simply minus 4. Number 40. Number 40. I'm close to finish. Number 40 said, how many words can be formed? How many words can be formed by using all the letters of the word awilo? Awilo, if the else are to be separated. Like I told you in the other one, we cannot get when they are separated once, but we can get when they are together. So without restriction, first of all, is without restriction, without any condition, without restriction. Without restriction, awilo is simply 1, 2, 3, 4, 5, 6. 6 factorial all over. The only one I have here is 2 factorial. So 6 factorial over 2 factorial is giving me 360 degrees. 360, not degrees. 360 ways without restriction. But when they are together, awilo being together, the L being together as one, awilo like this. How many are they? 1, 2, 3, 4, 5. So I'm having 5 factorial all over. There is no over because all of them are now 1, 1. And 5 factorial is 120. So when they are not together, else not together, or else being separated, is simply without restriction 360 minus when they are together. So what do you have? 240. 240 words can be formed. Okay? Aha. So very, very simple. So number 31, number 41. Number 41 say given that the universal set, the universal set is what? 1, 2, 3 up to 7. Okay? And then they are giving that set A is simply 2, 3, and 5. 2, 3, and 5. Okay? And set B is simply 2, 4, and 6. Then I say we should find A union B complement. Okay, first of all, you need A union B. A union B means to unite A and B, which is 2, 3, 4, 5, and 6. Then complement means remove it from the universal set. So the remaining now, if I remove their union from the universal set, I'm left with 1, 2, 3, 4, 5, 6, and 7. So I'm left with 1 and 7. So that is that. See, very, very simple question. So number 42. Number 42 said we should solve 4 raised to power 3x plus 2 is equal to 32 raised to power, don't know if that thing is x minus 1, I cannot see it very well, and 4 raised to power x. Let me assume that this is the answer. This is the question. So reduce everybody. If I reduce 2, I'm going to have 2 raised to power 2 bracket 3x plus 2. Okay? Reduce 32. 32 is 2 raised to power 5, which is what? 2 raised to power 5 bracket x minus 1 all over. Reduce this one, 2 raised to power 2 bracket x. Now, I'm having 2 raised to power, this time this, 6x plus 4 is equal to 2 raised to power what? 5x minus 5 all over what? 2 raised to power 2x. Now, according to indices, if you have divide, you should subtract. So I'm having 2 raised to power 6x plus 4 is equal to 2 raised to power 5x minus 5, then minus 2x. Okay? So this is what? 2 raised to power 6x plus 4 is equal to 2 raised to power, this minus this will give you 3x minus 5. Now 2 will take care of 2. So I'm left with 6x plus 4 is equal to 3x minus 5. So collect like x. 6x minus 3x is equal to what? Minus 5 minus 4. This and this will give you 3x is equal to this and this will give you minus 9. So x is equal to minus 9 over 3. So x is equal to what? Minus 3. Okay, so x is equal to minus 3. So number 43. Number 43 said that if z is equal to 3 plus I over 2 minus 5i, okay, then I said that we should find z plus 1 over z, okay. Now, which is z plus 1 over z is equal to z itself, which is 3 plus I over 2 minus 5i plus, now inverse of something means turn it around, so I'm going to have 2 minus 5i all over 3 plus I. Okay, now in addition of fraction, first of all is their LCM. So the LCM of this and this is bringing them together, 2 minus 5i and 3 plus I. When two of them divide this one cancel this, is many this time this is giving me that is 3 plus I all squared plus, when this divide this is cancel this, many this time this will give you 2 minus 5i all squared. So let me now clear. Square the first one 9, multiply the first one and the second one 3i, double it 6i, square the last one minus 1 plus square the first one 4, multiply the first one and the second one minus 10, double it minus 20i, square the last one and have plus 5. Okay, all over it's supposed to be plus 25, because 5 squared is 25 and I squared is minus 1. Minus 1 times the minus here will change it to plus. So let us clear this one. This time this will give me 6. This time this will give you what am I saying? This time this will give you plus 2i. This time this will give you minus 15i. This time this will give you plus 5. Okay, because I times I is minus 1. So I'm now left with, now let me add all the numbers. So I have 9 minus 1, okay, plus 4, then plus 25. So I'm having 37. So for the numbers I have 37, then for the I I'm having 14. Yes, 14. This and this is giving me minus 14i, okay, all over. This and this is giving me 11. Why this and this is giving me 13, right? Minus 13i. Then afterwards you have to rationalize if it is not in that. Okay, so we have to rationalize this. So to rationalize this now, in fact they're asking us the real part. Find the real part of that. So the real part of this is what they're asking us, not everything here, but let us rationalize. I'm having 37 minus 14i all over what? 11 minus 13i times 11 plus 13i all over 11 plus 13i. So let's go. So I'm having 37 times 11, 37 times 11. So 407. So 407, that is this time this. 37 times 13. 37 times 13. I'm having plus 481i. Okay? In fact, since they say the real part, since they say the real part, okay, I don't need to do everything. The real part, I know that what will give me the real part is this one times in this one, and this one times in this one. So this time this first. 37 times 11 is giving me 407. Now, the plus, because minus I times I will change the sign. So I'm left with 14 times 13. So 14 times 13, that is plus 182. All over. The same thing. This time this, 121. Minus plus, this time this, 13 times itself. 13 times itself. I'm having 169. So my answer is now 407 plus 182, which is 589 all over 121 plus 169, which is 209. Okay, so that is that. So I don't know if anything can divide. Okay, 290, not 209, 290. Okay, so 290 divided by 3. Okay, so that is that. So the next one, number 44. Number 44. Number 44 is giving us. Number 44 said, find the cardinality. Find the cardinality. Find the cardinality. Okay, find the cardinality of the set A, which is equal to a set of x, and that x is an element of integer such that 2 is less than x, which is less than 7. Okay, so which means solution, which means A itself, they wrote it in building form, so let us list it. Listing is said that 2 is less than x, which is x is greater than 2. So I'm starting from 3, 4, 5 and 6. I will not get to 7. So which means that n is 4. They are just 4. So the cardinality, which is n of A, is simply 4. That's all. Number 45. Cardinality means the number of all the elements of that set. Number 45 said, which of these is equal to tan squared theta or tan squared x. Okay, it's a very simple something. Okay, solution. Now tan squared x is same as saying tan is sine x times sine over cos. So sine squared x over cos squared x. Okay, but we know that sine squared x plus cos squared x is equal to 1, is it not? So let me make this subject. This one can move here to have that sine squared x is something as 1 minus cos squared x. So let me now put it here. This is equal, instead of writing sine squared x, I can put it as 1 minus cos squared x all over, bring this one down, cos squared x. Okay, now if I separate it, so tan squared x is the same as, let me separate it, 1 over cos squared x minus cos squared x over cos squared x. So I'm left with 1 divided by this will give you sec squared x. Okay, minus anything divided by itself 1. So that is the answer. That's all. Okay, so number what? Number 46. Remaining 2. Number 46. Number 46 said, if A is equal to 1, 2, and 3, okay, and B is equal to 0, 2, and 4, okay, then I said, list all the elements of A symmetric B. Okay, now A symmetric B is simply the difference between their union and intersection. That is A union B minus A intersection B, which is their union is simply bring everything together 0, 1, 2, 3, and 4, minus their intersection is what they have in common. They have only 2 in common. So the remaining one is now 0, 1, 3, and 4. Okay? Or symmetric is simply what they don't have in common. What they don't have in common. 1 is here, but 1 is not here. Okay, let me say 0 is here, but 0 is not here. 0. 1 is here, 1 is not here. 1. 2 is here, 2 is here, it's not among. 3 is here, 3 is not here. 3. And then 4. So symmetric simply means what they don't have in common. Okay? So that, or the difference between the union and the intersection. So number 47. Number 47 say given that set A is equal to A, B, C, and D. Okay? And set B is equal to A, C, D, and F. Okay? Then I say we should find A union B minus A minus B. Okay? Now A union B is simply for us to bring it together, which is what? A, B, C, D, and F. Okay? Minus A minus B means from A, remove everything that is in B. So A is here, B is not here, B, C is not here, C, and D is not here, D. Okay? A is here, A is not part. B, okay, C is here, C is here, so C is not part. So it's simply B and D, B and D. So remove B and D from here, so we are left with just A, C, and F. So number 48, which is the last one. Number 48 said, if alpha and beta are the roots of, if alpha and beta are the roots of x squared plus 4x minus 1 is equal to 0. Find, let me write it here. Find, look at what they say we should find. Find A minus B all squared. Now, the formula for this is simply alpha plus beta, not A, but alpha, sorry. Alpha minus beta all squared. So this is simply alpha plus beta all squared minus 4 alpha beta. Please know the formula. Just know it. And alpha plus beta is simply minus B over A all squared minus 4 into, this one is simply C over A. Okay, so this is what? Minus, this is, my A is 1. A is 1, the coefficient here. My B is 4, and my C is minus 1. So I'm having 4 over 1 minus 4 over 1 all squared minus 4 into minus 1 over 1. So I'm left with 16. 16 minus, it's 16 plus 4, which is what? 20. So that is that. So thank you very much for watching. Please like, share, and subscribe. Okay, God bless you. May the peace of the Lord be with you.